Welcome back. Next property in line is the time scaling. This is the third basic operation that we did in our signals and systems. Now, time scaling, that is, it results in compression or expansion of a signal depending upon the scaling factor, which means it will definitely alter your time period. Right? So if you have a signal x of t and this signal is periodic with some period, say t, then if you scale it, that is, you come up with a signal y of t, which is the time scaled version of x of t by some factor alpha. Alpha, जो हमारा condition है, it has to be a real positive number. And then you know that if alpha is greater than 1, it will result in compression. Those things we have done in our first chapter. So this will also be periodic. First thing is periodicity won't be altered by any of these operations. आप time shift कीजिए, आपका time shifted version, it will be periodic. आप time reversal कीजिए, आपका time reversal signal, it will be periodic. आप time scale कीजिए, आपका scale signal will be periodic provided alpha is a positive real number. But the difference is in shifting and reversal, nothing happens to the time period. Time period is preserved. But in scaling, your time period will change, right? And it will actually be divided by this factor. So thing is that if it has a period of t, then this y of t equal to x of alpha is also periodic with a period t by alpha. And obviously अगर टाइम पीरियड में डिवाइड हो रहा है जो आपका फंडामेंटल फ्रीक्वेंसी है, योर फंडामेंटल फ्रीक्वेंसी विल बी मल्टीप्लाइड बाय अल्फा. फाइन. So if I express this y of t, which is x of alpha t, as a Fourier series, it will be k running from minus infinity to plus infinity. You'll have a coefficient a of k, then e raised power j k alpha omega naught t, because your fundamental frequency will be multiplied by this scaling factor. Fine. So the thing is that it turns out कि जो आपका Fourier coefficient है, it still is a of k. Fine. So the Fourier coefficients have not changed, but the Fourier series representation as a whole has changed because of the change in the fundamental frequency. Fine. It's quite interesting. If I try to generalize it, आपके जो दो basic operations है, time shifting and time reversal, they don't change your time period. They keep the time period constant, which obviously means आपका fundamental frequency, it also remains the same. It doesn't vary. But they affect your Fourier coefficients. In the time shifting case, your coefficient gets multiplied by this exponential factor. And in the time reversal case, आपके कोफिशिएंट ही टाइम रिवर्स होते हैं. But time scaling में it alters your time period, it also alters your fundamental frequency, but it doesn't alter your coefficient as such. Right? So always remember this thing. So these were some important properties that we discussed. There are some more properties. If you wish, you can go through जो भी टेक्स्ट फॉलो कर रहे हैं, बट दीज बिकॉज वी आर डीलिंग विद वी आर यूजिंग दिस Fourier सीरीज है. इसके बाद जो भी फ्रीक्वेंसी रिप्रेजेंटेशंस होंगी, वी आर यूजिंग दैम टू फॉर द एनालिसिस ऑफ सिग्नल्स. एंड सो फार जो भी हमारा एनालिसिस हुआ है, इट हैज़ बीन इन टर्म्स ऑफ 3 बेसिक ऑपरेशंस. So we need to know what happens to these 3 basic operations in the Fourier series. Fine. So we have some other properties, like we have one property with regards to the multiplication. Okay, this is also regarded as what you call one of the prime operations, although it applies to the amplitude of this signal. But let's see what happens. How we can analyze what happens to multiplication in the Fourier series. So if I do a quick analysis, I have 2 signals, x of t, which transform, जिसका Fourier series gives coefficient say a of, say, a of n. Then I have another signal y of t. When I take Fourier series, I get coefficient, say, b of l. Obviously x of t and y of t, they will be periodic. And again here I am assuming that they both have the period t. Fine. Then we define a new signal z of t as the product of these two signals, x of t, y of t. And let's again suppose when we take the Fourier series expansion, let's say we have the coefficient c of k. Now we want to establish a relationship between this coefficient and these two individual coefficients. So we can do a bit of mathematics here. So if I express c of k, it will be 1 upon t tau x of t y of t e raised power minus j k omega naught t d of t. Fine. Then I can express this thing x of t, I can express as summation that runs over n, a of n e raised power j n omega naught t. And similarly y of t, again summation over l, b of l e raised power j l omega naught t. Then we have our own exponential factor. Fine. Then summation is a linear operation, so I can take these two summations simultaneously. Summation for n, summation for l, take the constants these coefficients like this. Then I can combine this and this exponential as, क्योंकि product has j n plus l omega naught t. Then we have our own exponential, and the integral is with respect to time t. Fine. Then we can also combine these two, so it will be 1 upon t over the time period t, two summations n and l, a of n, b of l, then e raised power, so how should I put it, let's take minus j, then k will be common, minus n plus l omega naught t. Let me just check, e raised power minus j. Okay, this is fine. Then 1 upon t, summation will take outside, summation n, summation l, and the associated coefficients, and integral over the time period t for this k minus n plus l and omega naught t dt. Now we are interested in this term, and it involves an exponential factor, right? So if we may have two cases here, if k is not equivalent to n plus l, you know that n, l and k, they are just integers, तो ये जो इंटीग्रल होगा देन टी ई रेज पावर माइनस जे, इसमें जो ये क्वांटिटी है के माइनस एन प्लस एल ओमेगा नॉट टी डी टी. Now if k is not equivalent to n plus l, which means k is either greater than n plus l, in which case it will be an integral like this j, let's use m, because when you manipulate integers you get a new integer, omega naught t dt. Yeah, if k is less than n plus l, you will get an integer like this. But these are both pure exponentials, and if you integrate, and because exponential signal is a periodic signal, if you integrate it over a time period t, both these integrals will have a value of unity. Fine. Now if k is equivalent to n plus l, then आपका जो exponential है, it will be e raised power 0 dt, which means it will be when you integrate this dt, it will be simply t. Fine. So if I take that particular case, if I continue with my this analysis, means C of k will be 1 upon t summation for n, summation for L, a of n, and L is, because I'm assuming this case k is equal to n plus L, so you can always express L as k minus n, so it will be b k minus n, then the value of this integral t, this and this will go, so I will have summation n. Now this summation will vanish because we have vanished the L factor, L अब है ही नहीं, so it will be a of n into b of k minus n. ठीक है, या if you express it in a better way, जो आपका c of k है, this summation n runs from minus infinity to plus infinity, a of n b of k minus n. ठीक है, under the condition k is equal to n plus l. Obviously if k is not equal to n plus l, so this case, in that case it will be simply 1 upon t summation n summation l a n b l. Okay. Okay, so this is what happens to, like I said, it doesn't have any practical implication because multiplication is an operation that operates on the dependent variable जो आपका amplitude है. But we need to understand the physical significance of the three basic operations which we have kind of discussed slightly. Fine. Like I said, there can be many other properties. We will be doing more properties, but in इसके बाद we'll take the Fourier transform, so we will be discussing some more properties there. Yeah, we'll be doing Laplace transform, the Z transform. Those are regarded as more rigorous tools for signal analysis when compared to Fourier series. So we will be discussing in detail some more properties when we take those kind of transforms. Right? So we'll stop here. This was all about Fourier series for the continuous time case. Next, we'll be taking the case if Fourier series is based on the fact you can use Fourier series only on periodic signals. That's x of t needs to be periodic. Then only you can compute the coefficients and express your signal x of t in terms of those coefficients. What if your signal is not periodic? Right? So उसके लिए we have separate analysis, and for a non-periodic signal we basically introduce the Fourier transform. Okay, so that will be following in the next video.